TLS itself is only involved with end-to-end encryption. It does not care about anything else. It does not care about the authenticity or the integrity of the data. As long as the data is encrypted, that's all that TLS cares about.
Welcome back to another episode of Coordinated. I think all of you who are CT nerds, you guys are seeing that lately there is a huge conversation about zkTLS. All the QLs, all the key, like the leaders of the space are talking about this thing. I was curious about this thing. I heard it back during DEF CON the first time. When I talked with Nader, there was a bunch of stuffs which were being built on Eigen, but studied myself but couldn't like actually grasp the entire thing, what it is actually about, why it's actually special. I think recently with the threads coming up, with the conversations which are coming up, I got, okay, this is something which we need to study more, which I think the audience of this pod needs to learn, and also the Eigen community as a whole. So I think I've got the best person in the zkTLS, if not the best, one of the best, who can guide us what zkTLS is actually about, and also the protocol is building on the space. So welcome, Madhavan. Thanks for doing this. Yeah.
Awesome. Super excited to be here. Yeah, zkTLS is like one of those topics that suddenly got a lot of limelight. But yeah, I think through this pod, we will talk about how the journey is otherwise pretty uneventful and boring. So happy to fill you in with all of those details as we talk. But maybe I'll quickly give an intro of myself, and then we can use that as a point to get into our conversation. So Reclay Protocol is a zkTLS solution. We've been building this for since like late 2022, I guess. And the key description of zkTLS is basically that you can log in into any website and then generate a zk proof of any data that you see on that web page. Right? So you can log into your bank account, generate a zk proof of your bank balance, log in into Amazon, generate a zk proof of stuff that you ordered on Amazon, and so on. That's largely what zkTLS itself is. And that of course that begs the question, okay, fine, this is a great technology, but what can you do with it? Like, where is it useful? Maybe I'll leave with that is, we are now working with like large enterprises, names that you might already be familiar with, um, who want to do stuff like education verification, like, hey, where did you study? Or employment verification, where do you work? Now, how do you prove stuff like this? Like, right now, the probably the only way to do it is like probably take a photograph of your student ID, or take a upload a PDF of your transcript from university. And that's like, everybody knows that's a shitty solution, right? A, you can morph the photos that you're taking, and B, it's really hard to verify whether that information is actually valid on whatever you're uploading, right? So instead, what these enterprises that are working with us are doing is they're saying, hey, I need to know whether you went to whatever IIT Kharagpur. I need you to log in into IIT Kharagpur's web portal and prove to me that you're able to log in and you're able to see your profile over there, which says your name, the degree that you're studying, your year of graduation, so on. We'll extract that information using zkTLS and share it with the enterprise. That way, they are sure that this data actually came from a trusted source, which is the university itself. So these are the kind of use cases that we are going after. Of course, the actual universe is larger. We're doing education verification, employment verification, government ID verification, financial background verification. So yeah, these are the kind of broad use cases that we are going after right now. And yeah, mostly trying to sell to enterprises that already have this need of having to verify information. That's what we are going after. But with that, I'll hand it back to you to let me know which direction you want to go further into.
Yeah. So I think this is a perfect way to start for us to think through it, to give us a one-liner description of zkTLS. If I understand correctly, it's like verifying any data in the internet. and you also laid down some use cases. We'll deep dive into each one of this, but I want to take a step back and want to understand why in the first place you started Reclaim. Like, what are the specific problems you saw which led you to start building in the zkTLS space?
Sure, sure, sure. Um, so back in like early 2021, we were running this, or we still run the platform called Questbook. Right, so Questbook is this grants management tool. Arbitrum, Polygon, Compound, all of these big names run their grant programs over there. And we have like thousands of people who are coming and applying to these grants. And as you know, a lot of people in crypto want to say pseudonymous, right? So a lot of people started coming to us and saying, "Hey, we want to apply to these grants, but we want to stay pseudonymous." And grant managers were like, "Okay, fine, but these people are claiming to have worked at Microsoft, Google, or have contributed to Ethereum core repositories. How do we verify without, knowing what their identity is?" So initially, we started off to solve just this problem. Like, hey, now there are people who are coming in and applying for grants. What are their credentials without revealing their identity? That's the problem that we started off with. In fact, back in the day, it was called Questbook Identity, because that's the problem that we were trying to solve. And um, while we were trying to solve that problem, we of course came across this particular way of doing it through the Deco research paper that was, I think, late 2020. So we discovered it probably like mm, early 2022 maybe, or late 2021, somewhere around that time. We discovered the Deco white paper, research paper, whatever, and and then we were like, yeah, that makes sense. Now we can use Web 2 data sources to generate user credentials. Sorry, I probably skipped a very important inflection point. That's a conversation with Eli from Starkware. I think he was the guy. I need to give due credit. He was the guy who, nudged me in the direction of, hey, why don't you look at HTTPS certificates and try to generate a ZK proof from that? That way you can bring Web2 data into ZK proofs. And yeah, the rest is history. I think since 2022, we've just been like trying to get things to work in a production ready way, with acceptable user experience. Yeah, that has been kind of the journey. Again, happy to dive deeper into what specifically we improved and how it mattered. But yeah, broadly speaking, it started off as like Questbook Identity. Then we realized, hey, the thing that we're solving seems to be like bigger than just Questbook Identity. So we decided to spin off a different brand called Reclaim Protocol so that other developers can also start using it.
Awesome. I think this is one of, I think many Web2 startups also do the similar stuff. I think a popular example can be Amazon. The entire AWS kind of spun off from their server. What I've studied, like, I think they have used EC2 and let's say S3 for solving their own problem. And then they found, okay, this is not our own problem, it's the problem of the mass. So they kind of like spun up as a separate brand, and that's itself is a huge thing at this moment. Cool. I think just when we started and you like started with a great kind of one liner that zkTLS got popular now. It is actually there for a few years, if not for a long time. I think Web3 has this problem of throwing jargons or narratives because maybe that might move the markets. But since you are building in ZK and you're coming from a fundamental standpoint, well, again, like to go a little bit in a fundamental level and want to understand a few things before we go into the real like technicalities and stuff. So, like imagine I'm somebody who has little to no knowledge about TLS itself, right? So, but I know a little bit. There is TLS in Web 2, and then there is zkTLS, which is a very Web 3 kind of thing. If you can draw a comparison, like where TLS is needed in internet and the evolution to zkTLS.
Sure, sure, sure. Before I answer that question, maybe while I answer this question, you'll realize that zkTLS is actually a misnomer. As you said, it's a jargon that kind of stuck, and the market ran with it. And from my perspective, it's best to not fight a meme once it's already out there. So no, we just have to go along with it, because now people know what it means when you say zkTLS. So doesn't matter to fight about the intricate details. But anyway, I'll answer your question. So look, TLS is basically what powers HTTPS, which is the end-to-end encryption. Right. So whenever you're, let's say, opening your bank account on your browser, you're logging in, putting your password, username, password, but all of the internet traffic actually goes through various nodes, right? Maybe 5 or 6 nodes before it actually reaches the bank's web server. um and lot of untrusted channels are being used in between. Like basically you can tap into the physical wire, or you could like be the controller of one of these nodes on the internet network. So there are a lot of ways where you can sniff out what data is being sent over the network, right? For those who are curious, like if you've used Wireshark before, you can basically see all the traffic that is being sent on your local network. The same can be done at like various levels, right? So for you to have the confidence to put in your username password onto your bank's website, you need to be sure that nobody else other than the bank itself is able to read the username and password that you're typing in, right? So basically, that's what end-to-end encryption means. Like only the two ends, which is you yourself, the customer, and the service provider, the bank, can read the data that is being transmitted between them. And the way to do this is this protocol called TLS, which basically does a Diffie-Hellman key exchange and then uses that to encrypt data that is being shared across between the client and the server, right? So TLS, I think, long story short, TLS is a way to do end-to-end encryption. I think that's what is most important in this context. There are a few more nuances. We could touch on it as we go if needed. Okay, now what is zkTLS, right? Now, TLS itself is only involved with end-to-end encryption. It does not care about anything else. It does not care about the authenticity or the integrity of the data. As long as the data is encrypted, that's all that TLS cares about. You cannot prove to anybody else, a third party, that hey, this is actually the data that came from, I don't know, Citibank.com, right? If I say, hey, look, here's a screenshot of Citibank telling me that I have $1 billion in my bank account, that's worthless because you cannot generate that proof that Citibank indeed sent this information. Cool. So what zkTLS does is it's actually a clever hack in which you can use the HTTPS certificates that were used to establish this end-to-end encryption to also generate a proof that this is actually the data that came in, right? So at a high level, what you're trying to do is, hey, this was the HTTPS certificate that was used to set up the end-to-end encrypted channel. That's number one. Number two, that same key that was generated for end-to-end encryption is what is the one that was used to encrypt the data that came from citibank.com. And look, inside this encrypted data, so and so information resides. Right. So if you put all of these things together, essentially you can say with a very high degree of certainty that yes, this is the data that came from citibank.com. So what we're trying to do is make a channel that is by definition not provable and convert that into provable, right? TLS by definition is not provable. Like it's only encrypted. It does not care about provability, but we add a few zk proofs on top of it to make it provable that this data came from a certain source that we care about. I know that's like a very convoluted answer. Happy to help simplify.
Yeah, like if I've understood correctly, correct me if I'm wrong, that like zkTLS is some sort of like with the TLS is a protocol which helps in end-to-end encryption, right? And all the existing Web2 ways of communication, if I say, doesn't verify is the where the data is from. Is the data being tampered with or not? With zkTLS, we can actually show that whatever data we are kind of transmitting is true. It's not being tampered. Is it a simplified way to say?
Yeah, you could say so. But what is even more important is uh, identifying the source of a certain information. Identifying that this came from citibank.com. That is important. I think that is what the HTTPS certificates link back to. Like the only people who have access to the private keys of the HTTPS certificate of citibank.com is probably Citibank's actual server. So that's kind of where the trust comes from.
Hmm. I think I was thinking to ask this question a little bit later, but since you just mentioned, I think it's the perfect time to ask. Is the What's the difference between then zkTLS with APIs? Because all the Web2 ways of using data from these sources is like, let's say Citibank has an API, right? I'm building a payments app. I need Citibank data. I'll use their API key. Maybe that's paid, maybe that's unpaid, but I'll get the data out of it. Why we need the zkTLS then? Like, what are the differentiated factors with API keys?
Yeah, I'll give you a good answer and a bad answer. I think the good answer is yes, if there's an API, you don't need zkTLS. The trust is already established. The problem that we are trying to tackle is there are a lot of these websites that do not have APIs or do not have an incentive to generate an API or probably are disincentivized to create an API. What do we do in those? I think that is probably the best way to look at zkTLS. Wherever there are no APIs or we do not expect APIs to come about in the near-term future, zkTLS is probably the right. Like a university, take a university. Like university does not have an incentive to expose an API, and even if they do expose an API, it's going to be different for every university. So anyway, uh, yeah, if the APIs exist, you usually do not need zkTLS except for one specific use case, which is if you want provability on chain, right? If you want to take the API responses and put it up on chain, um, how do you do that? I think that is where zkTLS can come in handy as well. But broadly speaking, the mental model I want people to walk away with is if an API exists, um, zkTLS is probably not very important.
Okay, I have two questions. One is, okay, you just mentioned that to bring our API data on chain, zkTLS might come into the picture. But let's say if you use oracles, right? The existing way oracles are operating, will it be a better way? Is it more trusted, or the zkTLS way is a better way to put this data on chain?
I don't think the question is between trusted and non-trusted. Oracles are good at bringing public data on chain, right? So if there is, let's say a coin feed or a price feed or something like that, it is public information. Like everybody has access to it, so you can use oracles to bring that information on chain. You don't need zkTLS for that. Um, However, if you want to bring private information on chain, if you want to bring the information of, hey, what is Satyaki's bank account balance on chain, you can't use an oracle for that. I think to bring user data on chain is probably where zkTLS is more useful. I would argue for the public sources, oracles are actually pretty good. They're probably better than using zkTLS. zkTLS might be an overkill for doing that kind of data.
Cool. And then the second question is, I was like, when I was like studying a little bit and researching a little bit about a few stuff, this question was kind of hitting me. This is one thing you mentioned in the talks and docs that we can bring kind of any data, private data, we can provide you some sort of that. But let's say there is SBI, right? In India, that's very popular chain of banks. They don't want to expose their API keys and they have host of data. Can Reclaim or any zkTLS protocol help us bring those data on chain?
That's the key essence. The key essence of zkTLS is even if a website does not have APIs, we can go get that data, right? Because as long as the end user is able to see that data, we can generate a proof for it. That's probably the rule of thumb almost. So if the bank wants to stop zkTLS, they would probably have to stop showing that data to the user as well. So as long as the user is able to see this data, we can generate a proof for it. And these are like the classic cases where zkTLS is most powerful, right? Is where SBI probably does not have an incentive to give out an API, or wants to charge a lot for it, or whatever, right? So there could be myriad of reasons because of which um no, using those APIs is not super friendly or does not even exist. So those are the cases where zkTLS can definitely come in and like help out.
Awesome. I think this itself is opening a like lot of use cases, right? Like there are these traditional companies who are in the internet, let's say for the last 10, 15 years, banks can be one classic example. And there are so many user data. I think most of India is banked. And like this government PSU kind of banks have all this data, talking from an Indian standpoint. And this kind of, I don't think like even if SBI will have an API that won't be properly maintained for obvious reasons, or maybe they can charge a bomb or something like that. But like as you flagged one thing that okay, if SBI, because don't you think it's kind of harming their policies of privacy? Like, let's say there are these policies and all right, tech policies that hey, we'll not share APIs, we'll not share data. A zkTLS protocol kind of not revealing their data. I think that's the essence of the ZK technology. But hey, we can now use the proof of that data and can do stuff, right? And if SBI comes out and figure out that thing, or anybody, any organization, will be like kind of be some kind of actions against this protocol, or on they will try to stop it, he will not reveal this or something like that? What's your opinion on this?
Yeah, I think I have like multiple opinions on this, obviously. First of all, let's address the highest level, which is probably legal, right? Is this even legal to do? We have gotten a lot of lawyers and people to actually study this and come up with an understanding. In fact, there's a great study actually also put up by Cooper from Variant, and I think one more author. I think they did a very comprehensive study and a post talking about this from a legal lens. But largely, it boils down to as long as zkTLS is generating proofs of data that is only of that particular user that is using the service, we are going to be clean, because that is anyway data that is mine, right? Like you are showing it to me, and I'm generating a proof that I was able to see it, and that there's nothing wrong with it. However, here's where the ice is a little thin. That is, uh, you in some services you can do more. For example, I could probably log in into LinkedIn, and I can generate a proof of whatever is there on my LinkedIn profile. Cool, no problem. But if I log in into LinkedIn and start crawling and pull Satyaki's data and pull parts data and whatever, um, now that is definitely not allowed. That might be illegal. So from a legal standpoint, as long as the user is logging in and generating a proof of only data that is strictly theirs, from a legal standpoint we would be covered. Okay, so that's the legal answer. um um the second answer is more technical. Now let's say SBI would say, hey, okay, fine, this is not something illegal that they're doing, but I don't want them to do it anyways. So they can try to make our life hard by you know trying to like block services or identify that we're doing. And that's like super hard to be really honest. I think that is where um in the short term, using using some form of decentralization is actually the answer. That is, make it like almost impossible for SBI to differentiate between the traffic that is coming from zkTLS or like a regular website. As long as SBI is not able to figure out the difference between the two, um, they will not be able to block, right? And as long as they're not able to block the website being rendered, we can keep generating these proofs. So I think the answer to that specific question is decentralization. And I'm I am a decentralization maxi, but I'm also very bearish on decentralization for the heck of decentralization. But this is a unique case where it really matters that we are decentralized to make the entire system more secure, more robust. The one that I just mentioned is just one of the dimensions, but there are a few more security reasons as well. But like decentralization seems to be the answer to actually make this like really robust against these kind of like technical attacks. So yeah, from a legal attack, you know, we are already pretty sorted. From a technical attack, we need like more decentralization.
One thing you mentioned that it's okay. I'm a user, right? If I need kind of my proof of data of that particular service, it's fine. But let's say somebody else is building some service, a third party, and they want SBI's data. And are they legally allowed, or are they like legally allowed to get the proof of the user data of that particular, like let's say LinkedIn or SBI?
That's an interaction that's strictly between the user and the service, right? So the user obviously has the right to their own data and like store that data however they want. You can take a screenshot, for example. Like taking a screenshot is not illegal. So you can definitely take a screenshot, and you can definitely upload a screenshot to another service. And that's exactly what is happening in zkTLS. It's practically, for all practical purposes, a screenshot that is tamper resistant. You're taking a screenshot, downloading it to your phone, and then somebody else needs it. Sure, you upload it over there. So that's not so much of a problem. For
Cool. I think there are some apps which kind of restrict you from taking screenshots. I think that is they're figured out with time. But I think they might need to come up with some counter mechanism where zkTLS protocol will unable to.
that on a website, right? You like there are some apps, sure, but mm, that's not for legal reasons. That is more for
For their like monopoly. Yeah.
yeah.
So okay, this kind of like kind of again making me question one thing, that there are kind of existing these services which provides APIs for, let's say, business reason, right? Like I think Twitter has a API, but that is insanely expensive. But let's say there is uh, reclaim comes in and exposing the same data in a cheaper way. Number one, is it possible at this moment kind of giving people proofs of Twitter data cheaper way? And number two is, if Twitter figures it out, won't they try to prevent the thing because it's hurting their business directly?
It's the same thing, like same answer as what I gave a little while earlier with SBI. From a legal standpoint, they can't block us. From a technical standpoint, we need to get decentralized before they start trying to block us. Right. So same, like there's no difference between Twitter not wanting to do it versus SBI not wanting to do it, right? So from that
But
perspective,
we can, right? We can create ZK proofs of Twitter data at this moment. And I think it will be cheaper, obviously, than Twitter API, if I'm not wrong.
yeah.
But
But
I think it's
that just like the devil is in the detail. Twitter API is obviously you can use to crawl a lot of information, including information of other people, which is going to be not acceptable even using zkTLS. Like that might get you into legal trouble. But as long as you're generating proofs only of your own profile, your own tweets, yeah, I think that should be all right. Um, but from my experience, the way that people use Twitter APIs is usually for like data of a lot of people, try to aggregate that kind of information. But if it's only like your own data and that's what you're trying to extract from Twitter and generate proof for it, I think that should be all right and definitely will be cheaper.
but then if, as you mentioned, I think if they want to get data of all, it's a problem, right? Twitter obviously won't be allowing that,
Yeah,
right?
I would discourage against that using zkTLS as well because it is not going to be legal.
Hmm. So, like, what will be your suggestion from being a zkTLS builder and Reclaim founder, where dev need not be web to normal dev, where they should use zkTLS protocols over APIs and like zkTLS in general? What are the use cases or the scenarios in which you can say?
I think broadly speaking, if an API exists, don't use zkTLS. Um, I think that would be my like umbrella advice. Almost always true. Um, unless you want to use those APIs on chain, but I'm going to keep that aside for a moment. If you're if you're like a Web2 company and you're not nothing to do with like on-chain interactions, which is in fact the biggest market for zkTLS. If you're doing something and then there is some API available for it, you usually do not need zkTLS. So go with the API. That's my advice. Um, However, if there are services that you need information from that do not have APIs, that is when you should look at zkTLS. Like again, going back to the same examples, right? Like banks or universities or payroll systems, government ID portals. These are places that typically do not have APIs but have like very important information about the user. I think that is the best place to use zkTLS. Intersection of important information about the user and no APIs. I think this is the a perfect match for zkTLS. And then, of course, if you want to take API responses on chain, yes, zkTLS is also a great idea for that.
I think about that when they kind of fetch the important information, they have to make sure that they are not crossing any legal thing. As you mentioned, in case of Twitter, if they kind of get data of other users, that can
Yeah.
be
I mean,
make the
I don't want to make too much fuss about this particular issue because it's not super rampant. Because this is a problem only for like 3 or 4 websites, right? But like social networks. Other than social networks, you usually do not have access to anybody else's information, anyways. So if you're going to do, let's say, your I don't know, bank account, right? You don't have access to anybody else's bank account, anyways. So this legal issue that I brought up around. Sorry, I might have harped on it too much, but it's a very small problem and is relevant only for social networks where this kind of crawling is even possible. So yeah, for most cases that is not even a relevant consideration.
like I am again harping on the same thing, but I myself want to be a little bit clear about this because I think it will be a question of many people because most of the things are very jargonish. Uh, Again, want to ask you a little question, like little bit question on the same paradigm before we go to the other things. Uh, if a, you mentioned that so it's a problem of social networks that you get access to other people's user data, but let's say I'm building an app and I need data of everybody, let's say bank information of everybody, right? And there are no policies. Let's say any bank has no XYZ policy about the getting data of other people or other people's data, other users' data, but they don't have an API. Now, let's say Reclaim comes in and fetches data for all the users. Is it possible? And is it uh, kind of legal? What do you think?
Well, it's hard to talk about counterfactuals. I mean, if there like if you're gonna start that statement with if there are no policies, I mean, yes, like if there are no policies, there's nothing legal to even enforce, then sure, yes, right? But I mean, are there websites that do not have a terms of use already? And I don't know. I don't think there are websites like that which do not have terms
They
of
will they will obviously have policies, right, against user data protection and all those stuff.
use. Yeah.
So we can't technically take other users' data, if I get it correctly. Or is it my question valid at the very first point? Like I am okay to like my question can be invalid itself if I'm
The
like
reason I'm struggling is because you started the question by saying if there are no policies. If there are no policies, yes, there is nothing legal to enforce. So in that world, it is legal to do this, maybe even crawling or whatever you want. But uh, what I'm trying to struggle with this particular answer is there are no examples of websites that I know that do not have policies. So kind of, uh, is in that yeah, counterfactual zone.
cool. I think one thing is like let's say okay, there are many like I think universities and all this. I think Swiggy, if I'm not wrong, is also listed in Reclaim. Okay, I can be wrong. There are like few other projects and apps which are listed, and I think they have providing us data in terms of like ZK proof data, right? How Reclaim is fetching data from them at this moment? Is it like an API where I can get data for all the users? And how have you kind of dealt with them? Like, what kind of data I'm getting from all these projects, first of all?
No, so no APIs, obviously. We do not have any partnership directly with, let's say, Swiggy. We can extract only information that you can see once you log in into that website. So if you log in into Swiggy, what are the things that you can see? You can probably see your name, you can see your address, you can see your order history. Those are the kind of things that you can see on your profile, right? So, and that is exactly the information that zkTLS is able to extract. And that's
Mm.
yeah, interesting use cases that people build using this information, but that's slightly different. Happy to go into that as well. But yeah, to answer your specific question, whatever data that you're able to see after you log in into swiggy.com or sbi.com, that is whatever information you're seeing on the screen. We can generate a proof for that in a secure legal way.
Cool. So, okay. So if somebody, and I'm not an engineer myself, particularly back end of things, want to know from you. Uh, let's say I log into Stigi or I log into SBI, right? And is there any mechanism beyond ZK, beyond cryptography, that where I can get my data, I can fetch my data myself? Let's say Swiggy has that dashboard. Can I get in a PDF or an Excel if I can request them, hey, I need my data? Is it possible at this moment?
I mean, if that service offers a PDF download, maybe yes, right? Like SBI, I'm guessing you can download your bank statement.
Statements. Yeah.
But on Swiggy, can I download my order history? I'm not sure, but it
So
depends.
this is where kind of reclaim comes in. I'm just trying to map out why I need reclaim. Like what's the current?
Even
Yeah.
if you have a PDF, right? Like, let's say you downloaded the PDF from SBI.com and you shared it with me. How do I know whether it came from SBI or not? Right? And you could have downloaded the SBI statement and like edited a bunch of fields and sent that to me. Now, how do I know that that PDF also is kind of accurate, right? So yeah, I think the zkTLS will hold even for PDFs, right? Like, what is the source of that PDF? Like, the PDF also was downloaded from somewhere. Now, was it downloaded from SBI.com or was it downloaded from fake SBI.com? Or was it not downloaded from anywhere? It was just created on a desktop. So that is what is more important, right? Than the data itself. More than the data, what is important is what is the source of that data? Is that source trustworthy? And of course, has the data been tampered after it has been retrieved from the source? So all of these put together is what generated zkTLS proves that is
I
actually.
think if I understand correctly, that the main use case, at least for now, of zkTLS is not the horizon of data or the variety of data, but actually the source of data or the trustworthiness of data. Hey, if I get a data from here, can I trust it? Or is it verified? If I is it correct? Is it a good way to think?
zkTLS does only two things. It verifies the authenticity and the integrity of data. Authenticity is, hey, where did the data originate? Where did it come from? SBI.com. And the integrity, was it modified or tampered with after the data came from SBI.com? The answer has to be no. So zkTLS basically provides for any data the authenticity and the integrity of that data.
Awesome, awesome. Cool. I think I was going too much into the API things and all the variety of data was I one can get. But since got a little bit clarity around that, want to know. I think there are lots of things. I think you tweeted and you wrote in your blog. But just if you can point out some real life examples, 5 examples, which this using zkTLS people are building on your protocol.
For sure, for sure. Depending on which angle you want me to go in, happy to talk about amazing Web3 apps that have been built, and also like Web2 enterprises that are using us. So in the Web3 world, like there two projects called ZK P2P and P2P Me, which are both on ramp off ramp solutions in the Americas and Asia respectively. Um, and they need to they're basically doing on ramp off ramp. That is basically you send fiat money either using UPI or Venmo or whatever. Let's say I send it to Satyaki, I send $100. Now Satyaki needs to send me 100 USDC. Now Um, what Satyaki would do is you put $100 into a smart contract, and I would send a proof that I have transferred $100 on Venmo or UPI to Satyaki, and generate a zk proof of that information and store that on the smart contract, and the smart contract can verify it automatically and send money to me in USDC. So this is like a way to on ramp, and this is like super popular, right? Like hundreds of thousands of dollars being done every month on both ZKB2P and P2P which are both amazing products in their respective regions. So that's one. The other product called 3Jane, which is doing on-chain credit. Um, Now they need information of, hey, what is your off-chain credit to even start with, right? And a bunch of other financial information from the off-chain world to be able to give you a credit score on chain. Now they are using the TLS and Reclaim protocol as well. And a bunch of, like, I'm happy to go over like more and more such use cases in the Web3 world, but also just want to like quickly touch upon the Web2 world. Is a lot of people want to do background verifications, like recruiters or lenders and stuff like this. They need to verify where you went to university, where you work, what's your government ID, stuff like that. So these are like our three top use cases in the Web2 world: education, employment, and government ID. So log in into your university portal and prove to me that you're a student, or log in into your payroll solution and prove to me where you work. I think those are kind of the use cases in the Web2 world.
Hmm. Awesome. I think we got a little bit about, not much, but little bit, because these are very technical stuff about what Reclaim solves and other applications. Want to go a little bit on the architectural point, starting with Eigenlayer. I think Reclaim and zkTLS is a very prominent Eigenlayer project. Sriram himself like advocates a lot about like with the innovation of zkTLS and all, particularly Reclaim. So want to know from you that where Reclaim is using Eigenlayer in the entire operations.
For sure. As I mentioned a little while back, it is super important for us to decentralize so that these SPIs of the world or Twitters of the world are not able to block us. I think for that we need like more and more nodes, aka operators, to be running nodes on the Reclaim network. And yeah, what better place to like quickly bootstrap that other than AVSs, right? So that infrastructure is already ready. There are people who are already willing to do the work and earn money for this. So it was a great opportunity for us to just like latch on to that existing market. So the market supply is already there for people who want to run nodes, which was not true before, right? Um, in fact, before we really discovered AVS, or maybe before AVS was like really popular, we were talking to like individuals and trying to see, hey, no, we are going to run a node a little into the future. Are you interested? And then we had to go beg them. Not all of them run nodes as part of their day job. So now there are people who run these nodes as part of a day job and want to run more nodes on the Eigen network, and I think that's super convenient for us, and that's where we use Eigen.
Yeah, I think this is where the Eigen operators, as you mentioned, come in. They are like running nodes for all. If they want to run the Reclaim AVS node, I think that's additional income for them, obviously, and also the Reclaim can get a set of operators straight away. Just want to just ask a second order question there. Where exactly what are the tasks of these operators? Will it for generating these proofs or something else?
No, so it's the nodes on our service are called attesters. Now the attester is doing just one thing, as the name suggests, attestations on the encrypted data that is being transferred between the client and the server, and that attestation, along with the encrypted data, is then used on the client side to generate zk proofs. So the zk proofs are always generated on the client side, and the attester, all that it is basically an HTTP proxy, right? You can think of it like an Nginx or something like that with like 4 lines of code added to it, which is basically just giving attestation X. This is the encrypted data that I saw that went from the client to the server. This is the encrypted data that I saw go from the server to the client. and gives a signature to that, and then that signature is then used on the client side to generate zk proof.
Awesome. I think want to touch base little bit on the ZK side of things, but I want to ask a little bit spicy question out here. That there is another Eigenlayer protocol who is building this kind of solving similar problem. I'm not naming them directly, but want to know that what's the like the difference between these two protocols, like Reclaim and the other one, and what are the edges over this, or is it the architecture difference or application difference? What do you think about those? Yeah.
I mean, look, there are going to be differences, but I think there's way too small for us to make a big deal out of it. Sure, we can go talk about our specific implementation differences, but I think that's completely besides the point. I think both, uh, in fact, all there are a bunch of zkTLS projects, on or outside the Eigen ecosystem. I think everybody's trying to do the same thing. That is, like, try to make Web 2 data more open and composable. I think, yeah, of course there are going to be differences, right? In like every implementation, that does not necessarily make one better or worse. I think it's too early to kind of talk about that. I know if you ask like various people across the ecosystem, they would try to claim that their solution is superior. I mean, there's a case to be made for Reclaim protocol as well, but I explicitly try to um, keep away from that conversation, because that's a conversation that does not matter. What matters is what are the kind of use cases that are going to get enabled, and like relentlessly go after that. And of course, there are going to be differences in the way that people are going to implement it. It'll always be there. That's the nature of free markets, and yeah, that's what everybody needs to be focused on. I think it's the architectural differences or like technical differences is just something that catches on Twitter, because that's the only thing that's actually different, right? Like how many other places do you see like do you see PayPal and Stripe discuss about what database they use? Not so much, because that doesn't matter. I think we as an industry need to grow into talking about things that really matter, and not so much about the things that don't.
Samir, I think I have personally I haven't seen you much in all these Twitter beefs. Maybe a one-word reply or so. But yeah, I think that shows about your kind of trait or personality about focusing on real stuff, not focusing on all the debates which are going on. And yeah, I think coming to the end of the show, want to touch a little bit on the ZK side of things. I think we have touched a lot of the technical stuff and applications. One is a kind of, if you can, I think you've discussed a lot, but haven't asked you specifically about the ZK side of things which you are using. The reason of asking is because what I personally know that ZK is good. It solves a lot of problem. It's one of the cutting edge innovations of our generation, but it's slow. It's not scalable, and there are lots of high computational costs for generating these proofs. So how Reclaim is solving that, and where we are at the ZK pace of development in terms of Reclaim.
Look, I don't think that's true. I don't think ZK is slow or not scalable. I think that is true only for stuff like ZK VMs, right? So ZK VMs, of course, have ZK VM, ZK rollups. Those are like heavy computation. Like you need a lot of computation that actually goes in. There's not a shit on them by any means. I think they're doing great work and pushing the boundaries. But my point really is that's probably a very big problem for ZK rollups and ZK VMs. The ZK part itself for zkTLS is actually very, very lightweight. Um, uh, and the existing systems are already very, very good. Like we snark.js obviously has gotten very good. Sorry, Circom has gotten very good. Narc has gotten very good. Nor is up and coming. And that's also very good. So basically, yeah, all of these new age frameworks are actually extremely efficient. Like kudos to the engineers behind these projects. I think Reclaim protocol, when we were doing the early prototypes in 2021, I remember using Socrates, which was not the library back in the day, it used to take like 15 minutes for us to generate a proof on a mobile phone. And obviously that's unacceptable UX. But now the tooling has gotten much better, and the systems have gotten much better. So yeah, I don't think I don't think that statement that ZK itself is unscalable and too expensive is a fair argument. Uh, but I understand where the question is coming from, because that is what covers most of the discourse in the public forums, largely because the most important or the biggest use case of ZK that we've seen so far is probably ZK rollups and ZK VMs thereby, right? And for them, yes, there's a huge problem, and a lot of smart teams are trying to work around it. But I would argue zkTLS is like one of those unique use cases in which the ZK compute is not super heavy, and that's why it actually like took off the way it did.
Awesome. I think just like drawing the conclusion to this episode is, I think Reclaim is, as you started in the episode, Reclaim is one of the very few protocols, at least what I see, as lots of applications which are already being live, especially in the Web 2 era, because that I think that is where we get the maximum chunk of users. Because in Web 3, for most protocols, be it infra, be it apps, we are selling to the makers and makers and selling to the users. It's the same cycle we are rotating. I think for us to grow as a space, we have to grow the pie. And Reclaim is already doing that by integrating, as you mentioned, that how we can integrate Web2 data more on chain, more verified, more transparent, tamper proof, and being censorship resistant. Uh, Want to know what are the next plans of development for Reclaim? Like, what are the immediate goals you have? Anything new which we might see in? And yeah.
Unfortunately, I'm going to give you a bad answer, which is the next few months is going to be extremely boring. We are not going to be probably doing anything um very new, but largely it's going to be focused on making it more stable, more robust, just making what we already have like extremely production ready. It's already production ready, but like, you know, things always have to improve. So over the next few months we're going to be really consolidating everything that we have, and just onboarding customers, right? So I think the product the product experimentation kind of thing, we are not building MVPs anymore. So we are past that stage. Now we need to get real adoption, and I think that's where the focus is going to be. So from a what that means from a product standpoint is, everything needs to be more stable, and it needs to um really work for products that have hundreds of millions of users. So and we are in deals with a bunch of such customers. So no, we can't be a hacky project anymore. So you stop seeing us being that hacky project and like launching stuff like every day. But you'll see us ship a lot, but most of those ships are going to be bug fixing and like boring maintenance stuff.
Awesome, awesome. I think awesome. I think had a nice time chatting with you. Ask questions. Thanks for answering all the questions I had. I think it's a good starting point. I think Reclaim and zkTLS, that is a too complex a thing to sum up in a 50 minutes episode. But yeah, I think super thanks for answering all the questions transparently and being candid and being as much detailed as possible. We'll love to host again you soon and coordinate it.
Awesome. Thank you so much, Satyaki, for having me. And yeah, this was a fun conversation. I hope it was at least a little useful for our audience.
Yep, definitely. Yep.